Hello there, it's Jay here from Jay's Vintage Junk, and today we're pretty much starting off where we left off from on the previous video, to be honest. Basically, I'm pretty confident that we've now got a working motherboard. The problem is that we now need to find a way of getting the video out of the non-standard video coming off this main motherboard onto some kind of display, so we can actually see what we're doing and then we can actually progress on with the project a bit more. Now, I thought I actually had a circuit which would work. This is it here. I'll show you quick. This is what I've been playing with basically from when I first started trying to get a video out of this thing. Essentially what we've got a 7404, because that's the main problem with the Amstrad's video output, is basically all the signals, they're basically the same as what you'd find on a standard PC with a CJ output. The difference, I mean, there are some other video modes, it isn't exactly CJ, but it's basically CJ. But the signals are all inverted. So if you plug it into, well, for one thing, you can't plug it into a standard CJ monitor because the Amstrad gives out a composite sync signal, as where a CJ monitor, a VJ, EJ monitor, they all have a horizontal and a vertical sync signal. So these are basically the issues that we've got now. What I was hoping with that circuit there, it's kind of like an amalgamation of two circuits I found online. One where someone was basically using the inverter side of this to feed the signal into one of those, you know, those cheap Chinese video scalers. I can't remember, is it a GV something or other? I can't remember off the top of my head. But lots of people have played with them. You've basically got a composite and RGB input, digital. And is it digital? I think it could be analog or digital, and it converts it up to a VGA signal. It's a frequency converter basically, and he'd used the 7404 in front of the signal to feed into one of those and managed to get an output on a VGA monitor. I've used basically the same as that, and I've also the resistor network there is a really simple way of converting a TTL video signal into an analog video signal and blending the intensity signal in there, so it actually does have the intensity pin working. I've used that part of the circuit before and it worked, but at the moment, the idea of that is that basically we could just get the signal to work on just a TV with a SCART connector or something like that, just standard analog RGB. Unfortunately, I can't get that to work. I'll get you down on the bench here and we can have a quick look at the circuit I've got built up here and show you. I can't understand actually why it's not working, because basically what I've done there is very, very similar to how Amstrad do it in their monitors. Especially, I mean, like the mono monitor, that really is quite simple how the video circuitry works, and I do have the Amstrad service manual here with all the schematics for the colour and the mono monitors, and they're using a 7404, same as me, and it seems to work for them, and obviously it does work for them, but I currently have not been able to get that to work. But anyway, we'll get you down on the bench and you can see what I've got connected up here and see what's working and what's not working. So get set up and we'll be back in a sec. Right, okay, we've got the circuit I built up basically here. I'll switch the computer on. So that's the main board running now. I take the oscilloscope probe, and all these colours are basically what they are. So yellow's our sync wire, red, green, blue obviously is our RGB signal, the white wire is intensity, black's ground. If I probe on what is basically going to be the sync pin, which is 1, 2, 3, that one there, as you can see, we've got a sync signal there. Now this being a 7404, the next pin down should be the inversion of that signal. So we go to the next pin down, and there's nothing there at all. We're not getting anything coming out. You see, that's the input to the gate. You can see a signal there. Now we should have the inverse of that signal on the output of that gate. If we go to the output of that gate, there's nothing there. And I have tested this 7404, and it's definitely a good working 7404. But we can say this, like, we can have a look at the RGB lines. Let's try. Well, green's a good one because green's what you use for your black and white signal, for a mono signal. So let's go on to green, and again we've got a signal there. We'll go on to the next pin down, which should be the output from that. There's nothing there, it's dead. And I can't work out basically the difference that I have, why it won't work here when it's essentially the same in the actual Amstrad monitor, and it does. I have even tried a couple of different 7404s and even a couple of 7414s, which is a pin compatible device, and it's exactly the same. I just can't seem to be able to get anything on the output of the gates. But I did try something, possibly a little bit naughty, but it does show that we've definitely got a video output coming out of this thing. Just switch the scope off for a sec. What I can do, just find my, yeah, that'll do, screwdriver. Now, obviously these signals will be messed up, but if I pull out the 7404 and put that to one side, I'll take a couple of bits of all component lead, and I'm basically bypassing the gates, so we've not got an IC in there. So basically that's bypassing the gate there for the sync signal, and we'll do the, because we know that this would output basically a mono signal, I'm just going to also bypass the gate for the green signal. That one, that's them two there. So basically if you look there, I've just put a couple of jumpers in to bridge them two gates. So we've bridged the gate for the sync signal, and we've bridged the gate for the green from the RGB signal. We're not bothered about the intensity or anything like that. Now if I switch back, in fact what I'll do is I'll get you over onto what I'm using as a bit of a test monitor just for the moment for this. I think I'll have to zoom you out a bit. There we go. We'll switch that on. So that should be coming on. Yeah, there we go, that's working. Now if I switch the computer on, so that's the computer running, you watch this screen. You see this here? Now it can't sync to it, but we've got a memory count going up on the computer there. I'm pretty sure that's what that is showing up there, because obviously it's not right, it's not syncing to it, and all the signals are inverted, so it's not going to get a right picture out of it. But it, oh, I'm showing you the wrong screen there, sorry. It's that screen there you should be looking at. Let me switch it off and back on, and you'll definitely see what I'm talking about. So it's off now. We've just got a blank raster there. I switch the computer on. You give it a second. You can see it there coming up the screen. We've definitely got a video signal actually being outputted from the computer. like I said, obviously, like I said, all the signals are inverted. It's not what this monitor is expecting, but it does prove that the Amstrad is actually outputting a video signal. So we'll switch that off again. We'll turn that off. So I think what I'm going to do now, we will we'll get the breadboard out, because I should have done this in the first place rather than just expecting this circuit to work. I should have prototyped it on a breadboard first and actually see where I could actually get it working on the breadboard, and then made it up like this. But I was being a bit too hasty. I was rushing into it because I really wanted to see if I could get the computer working first off. So like I said, I was pretty sure that that circuit there would work, so I just went ahead and just made it up on the board, and I have checked and double checked that I've wired it up as per that, and I have. So it's obviously, like I said, this is not going to work. We're going to have to try some other things. So I've got a my breadboard here. This is fantastic. This is a really useful piece of kit, especially within a large one here. You can actually work on a couple of projects at once. You can decide a project for there, or whatever you want. This is what I was messing with, which I mentioned in the other video. Basically, we've got an LM1881 there. The idea of this is I have got a CJ compatible PC monitor. That will take a composite sync signal in, and it will split it so we can get a horizontal and a vertical sync signal. What I'm hoping is with a 7404 we can basically get the signal out of the Amstrad, invert the signals, then take the composite signal, split it using that, so we've got a horizontal and a vertical signal, and then basically feed the RGB, the intensity, and the H-Sync and V-Sync actually into a standard CJ PC monitor. That's my plan at the moment anyway, so that's what I'm going to try and do now. So I will be right back as soon as I've basically put something together on this board that I can show you. So back in a sec. Okay, I'm pleased to say I've actually made some progress, and it's me, I'm an idiot. I wasn't reading the schematic right. Essentially what I've done, we need a 100 ohm and a 75 ohm resistor actually in front of the signal going into the inverter to create this little potential divider. I've spotted that on the original schematic. I've actually just mocked that up on the breadboard here. And if you look on the scope there, I'll switch the circuit on. I've just got that running off my bench supply at the back there. I will switch the Amstrad on. That's the Amstrad on. If I take my scope probe, and if I scope the input of the sync signal here, if I can get in here and not disturb the entire circuit, because this is a little bit precarious, as is breadboarding usually is. But if I touch on there, as we can see, we've got the sync signal going into the inverter IC. And if I go on the next gate now, as you can see, we've actually got it coming out again. I've also connected up the green signal here as well, and again, if I show you this now, this is on the input to the green signal. And if we look there, we can see the pulses down. Now if I go on to the output of that gate, look, you see we've got up. So the inverter is actually working, it's doing what it's meant to do. Now the signal coming out of that is going to be far too hot at the moment to put into my monitor there. Like I said, I think the signal is going to be too hot. So what I need to do is add a few resistors. I think I used 560 ohm when I was messing about with that circuit there. bear with me, I'm going to have a fiddle about in my resistor pile, see if I've got something suitable. And we will, I don't know why I'm leaving you up there, we will try and add some resistors to the output of that and see whether we can actually get something meaningful of a display on that CRT. So just bear with me a sec. Right, basically all I've done at the moment, I've added a couple of 470 ohm resistors to the output of that. I've connected up the sync signal and the green signal to this monitor. We'll get you up on the monitor. And we've still not got, it's still not working, but if I switch on, we'll let the computer boot up. If we look here now, we are almost getting something which is nearly actually readable. If you can see that now. So it's not right yet, it's obviously coming up with its disk boot failure there. But we're nearly getting an actual usable video signal out of this. Now it could be, all that muck and rubbish could be down to the absolute just rat's nest of wiring that I've got here for getting it working. We might have to perhaps try a potential divider on the output. What I might do actually, which is what I was fiddling about with on this, is if I've got any more, those are 470 ohm trim pots. It could just be it just needs dialing in. So it's nearly there, you can almost see a usable image there. So let me just fiddle a little bit more and we'll see if we can actually get that image there to stop rolling. But we do actually have, for once, graphics on the screen. Like I said, I know it's not right, but it's coming. It's nearly there. Let's see if we can get it a little bit better. Okay, I've actually just removed that 470 ohm resistor there, which I connected onto the output from the sync signal. So basically we've got a 470 ohm resistor coming off the output from the green signal, which is going into that wire there. So that's coming out of the 7414 into that 470 ohm resistor there, out of that and down to the TV. The sync signal is basically going through the 7414 and straight out to the TV. So there's no resistance on that at all. And if we go over to the TV now, I'm pointing at the wrong thing there. Oh, hang on a minute, let me zoom you out a bit. I forgot I zoomed in. Are we on the right TV? I think we're on the right TV. No, that's the right TV. That's what you want to be looking at. So that's all connected up. Anyway, I power the computer up now. Hopefully. Now, why is it flickering like that before? Because when I've just fiddled with it off camera, I very nearly had a perfect. There we go. I can't stop it rolling. I'm not sure yet why we've got that roll to it, but if you look there, we actually have, I can read that. I mean, like I say, it's still rolling. I still haven't figured out quite what we've got to do about sorting the roll out yet. But faulty floppy drive, disk controller, or drive failure. So we actually definitely have a functioning computer, and we actually have a display. Let me just switch off, let me switch back on, and let's see if we can get that to... See, it seems to be struggling now, but it will then just... There we go. So like I said, we've nearly got it. we've definitely got a working video signal coming out of this computer. Okay, it's still rolling and everything, but the great thing about it is it proves that the motherboard's working. So just changing those DRAMs on the main board was all we needed to actually get that basically functioning. And this now we can actually get into something which is going to be an actual proper output device. Like I said, that was just, we've proved the concept. We've now definitely got the idea of the inverter working. That definitely works the way I want it to. And all it was is we needed that potential divider on the input of it. And if you actually look at the circuit, let me just get you zoomed in over here. Hopefully you can see the screen on my laptop. Oops. There we go. This is what I'm actually talking about. Let's see if I can get you in. That's as close as I can get you. But basically, you see. Let's see if I can get you down a little bit. And out a little bit. But basically, what I'm showing you there, you can see that all right. Hopefully. Let me see. Yeah. Basically, this is the part. This is the input of the colour monitor. It doesn't really matter for what we're doing, but we've got our DIMM plug in there. We've got our RGB signals. We've got our intensity, a black signal, which is something that's specifically Amstrad, but we don't really have to worry about at the moment. And we've got our intensity pin. And essentially, what it does is it comes up, and there's the 74. It's a 7404. I've actually got a 7414 in there at the moment, but I don't think it matters too much for this circuit. And as you can see, each one of the lines goes through one of the gates on the 7404. What I'd forgotten about, if you look on this side here, we have a 100 ohm resistor between the signal and the actual gate. And we've also, it's like a potential divider because we've also got a 75 ohm resistor from that point to ground. And that's what I'd missed out on my circuit. As soon as I implemented that, it started working. And like I said, I've only got the very most basic of this setup at the moment. I've literally just got the composite sink, and I've got the green connected up, and that has actually given us a signal. That's given me the confidence to fiddle about with this circuit a bit more and actually see what I can come up with that's going to be a little bit more permanent than this. But yeah, we have got progress. We definitely actually have video coming out of the main board. Anyway, I'm going to leave it there for now for this for today. I'm going to have a bit of a think offline and figure out exactly how I'm going to go about this. I'm still not 100% sure what I'm going to want to use as my main end monitor and how I want to come up with it. So I've got a few ideas. We could either use this nice CGA monitor. In fact, I'll just show you my nice CGA monitor. It's not actually a CGA monitor, to be totally fair. Oop. Let me get you zoomed up and you can hopefully see it. I've had this in storage for many years. It's this one here. It's a Unisys, and it's a 14-inch. It's quite a nice monitor. It's actually an EGA monitor, which is nice. EGA monitors are hard to find. They are a rare beast. But this is a true EGA colour monitor. Fortunately, and I didn't actually know this, I always thought this was a CJ monitor until I started Googling the model number of it. Actually, when I started fiddling about with this thing, and it turns out it's not a CJ monitor, it's an EJ monitor. But EJ monitors, the way that the pinout works and everything on them, are actually backwards compatible with the CGA standard. Even though the way that the plug's wired is slightly different, as in you have 2 reds, 2 greens, 2. Let me get you down so you can see my face while I'm talking these things. You've actually, on an EJ video standard, you've got 2 reds, 2 greens, 2 blues. You have a standard red, standard green, standard blue, and then you have like the enhanced one. But the way that the DIN plug, the 9-pin DIN's actually wired, is that the standard red, green and blue correspond with the red, green and blue pin out for a CGA monitor. The horizontal and vertical outputs are exactly the same, and what would be the CGA's intensity pin is the intensity pin when the monitor is inputting a CGA signal, but it's used for another purpose when there's an EGA signal going into the monitor. So you know, it can tell whether it's got a CGA going up it or an EGA going up it. I didn't know that. I thought that was just a standard stock CGA monitor. I've had it for years. I've had that thing since the 90s. So that's a nice thing. And I'm wondering, do I use that monitor with the Amstrad? It would be a nice monitor to use with it. And if I ever got a 1640 main board, we should be able to get it to output EGA, because like I said, that is the standard for that monitor. Anyway, the other option, like I said, I'm actually having some issues trying to get the RGB working on the S4000 console. All the composite monitors on that and all the composite inputs work perfectly, but I'm still having some issues with the RGB inputs. But like I said, I broke off that project to play with this project, and I can only have so many projects going at once, and I do have other monitors. Or do I make a little box so I can just use it with a TV? I don't know whether. In fact, I'm going to have a play with perhaps connecting it up to a standard LCD with a SCART on it, see what kind of output we can get from that. Obviously we need to stop it rolling. There's something obviously not quite right with the sync yet, or it could just be that old TV that I'm working. So like I'm going to carry on playing with that off camera, and as soon as I get something that's remotely interesting to show you, I'll make another video and we'll get all that. I want to get basically a nice output from the Amstrad before we move on with the projects and start doing some of the other things that the computer needs. Anyway, I'm going to leave it there for now, because I don't want to make another massive epic long video. The other one was an hour long, and I've made a video, I think it ended up as 2 hours long, and I'm trying to keep my videos between, I don't know, when it's something like this, I'm fiddling with the Amstrads or fiddling with a computer. If I can keep them between 30 minutes, an hour and a half, absolute tops, it'd be nice, because otherwise I think people start getting a bit bored if my videos drag on too long. Anyway, I'm starting to rant and ramble now, so I'm going to leave it there for now. I hope you enjoyed this little update on the projects. I know there were a couple of people that wanted to see, you know, what I was playing with on the breadboards when I just showed it at the start of the last video. So thanks for watching, and goodbye.